Oh, with just 30 seconds speaking time left. Oh. Could get hard. So, intent-driven, fully automated deployment of Anycasted load balancers with HAProxy and Python. A long title, but excuse us, we are from a university. We have to do something like that. So, who are we? Johannes Kampmeier, I'm Sebastian Langenhorst. Great introduction, by the way. We are from a mid-sized university in the middle of Germany called Paderborn. Figures, we have 20-something thousand students, 2,500 employees. Different departments. Every department stands for itself, but if it's anything to do with IT, they end up eventually at us. So, managed service, hosting, application development, network, email, everything is done by the IMT, the Central Computing Department. Okay. To maintain all this, we have quite some infrastructure. We need a load balancer, of course, to do so. We had a quite big, pricey IP solution before that went out of everything, so we had to replace it and took a look at the market. And one product stood out, HAProxy. So we tried to use HAProxy for everything we do. So we do LDAP, we do mail, we do web server, like everything we have with HAProxy. What's our approach? We went on, got us 2 off-the-shelf rack servers from a standing contract. We put quite a lot of resources on them. So it's 56 cores, 100 gig of RAM, because we didn't know what do we really need. The NICs are 10 Gbit. That's okay for us since our backbone just has 40. So with 2 of them, we could exploit it. What we do right now, quite an approach that it's even documented with please don't do it. We do it anyway. For each VIP, or for each VIP, we have a single process with a single config. This allows us to reload, to replace a single VIP without affecting any of the others. We didn't know if we really need it. Right now we can do it. We have enough hardware to just do it some time before it gets a problem. We went for an active-active setup with the VIPs. Now it's just around 150. Get Anycasted to both load balancers. So we have an Anycast structure above HAProxy. How do we do it? We have an Anycast health checker that checks if the HAProxy is up and running, then announces it via BERT to root reflectors, and then they will announce it to the network switches. Even if we do quite something for the university, we are quite a small department, so we rely on heavy automation. If we can't automatize anything, we can't write it per hand. That's just impossible. So we deployed via config deployment, and what happened to be really nice is a graceful reloading with HAProxy, so it doesn't break anything. What we do, with former solution, everything was routed through the load balancer. We wanted to go back from that, so that the routers are routing and the load balancer is load balancing. So we don't have a single point of failure. So we still have a single point of failure. But we had the problem that our ACLs on the routers didn't match on the load balancer. With HAProxy, we wanted to get a solution for this. So we use termination on the HAProxy. We make heavy use of the proxy protocol whenever it's possible. If it's not possible and it's HTTP, we use X-forwarded for connections. Another request or demand yeah, it's more demand. From our web team was, we don't want to have anything to do with SSL, with TLS. Please terminate. So we terminate everything that has something to do with TLS on the HAProxy. Sorry. That is wonderful for us. For the first time, we have a consistent SSL cipher out there. We have a consistent TLS version that we are supporting or not supporting. That's in security, it's great. Still, active-active is nice, but we have some interesting products, I will call them, which still require that we are rooting on the HAProxy. Thanks to the TProxy extension, it's still possible to use HAProxy as a front end and then transparently tunnel through HAProxy and root. There's one product we have that uses client IP as a session key. It's a real good idea. But we can't replace it. It's another department, so we have to work around it. OK. In a picture, how does it look? In the introduction, you heard I'm mainly application. So with our old load balancer, we had the load balancing with a network. Our networking people didn't like it, so with HAProxy, we got in the application team the load balancer. This way, it's nice that we don't have to do anything with the switches or with the routers. Sorry, I'm no networking guy. So we don't have to have any access to the routers. We go through the root reflectors, HAProxy, and the service backends. Everything feeds out of one config deployment. And whenever something new appears or some change appears, Anycast health checker will notice on the HAProxy machines, will then, via BERT, tell the root reflectors, and those then announce the BGP routes to the data center routers. So everything we need, and with the root reflectors, we have an additional layer of security there. OK. Our configuration management is, I don't know if anybody has ever heard of it. It's rather unusual. It's called BCFG2. It has, like the most, no concept of services, but of hosts. So it can configure hosts, but no services. It uses groups to manage actually the hosts. So we have different groups like web server and a group typo 3, and productive or unstable or testing. And with a layer of these groups or with a subgroup of these groups, we can address one machine. So that's what we have. It's implemented in Python, so it's easy extensible. It supports common templating languages, which we make some use of, or some heavy use of. And since it's Python, it's easy extensible to outside use. So if there's some data we can source from anywhere, we can get it within our config deployment, config management, and make use of it. OK, that made us to get the idea that we could possibly make some wholesome automated approach to get HAProxy or HAProxy to run. And that's Johannes' part.
Thank you. So now my part, the buzzword part. We have an intent-driven architecture. So what would you even call intent in that case? So for us, our most common use case is for a web development team. They have some kind of requirement, and they say, OK, please, I want this FQDN balanced to these backends with these options. And the only way for us to manage this, because we had no way to define this in our current config management, we said, OK, we create a consistent definition of a service, and all devices and applications that need to be configured simply source this data and we generate the configuration for them. So HAProxy is currently deployed by this. We are using it for net filters, which is nice because when we define, okay, this service needs these access ports and this protocol, we simply know, okay, we don't need anything else. So close everything, every other connection. We are heavily monitoring with Isinga2. So if we know a service is running on HTTP, we can check the liveness with active checks on the HAProxy front end and also the back ends if they are living. And also this works for our mail servers and whatever you like, because it's extensible. And the best thing is it's a single source of information. So we simply say, if it's not there, it doesn't exist for us. So how do you call the system if you're not shipping this as a product? So it's the service magic. And our design approach was pretty simple. We said, okay, we need a file system-based approach because we have an implicit hierarchy and we can give access to different groups on different levels of the tree so they can define their defaults there. And such a defaults file is basically overwriting all the defaults set up to this level. So if one has the web team has another service, they create a new folder, add a new defaults file, and they have defaults for every type of service they want to deploy as such. And the best thing about this is you don't have to specify all fields that we support because most things we can simply infer. So if you have a service file like here on the right, and you see that we have SSL turned on, and we say the SSL redirect is false. We know, okay, the HTTP server is doing the redirecting. Also, the nice thing about this is we have a lot of service owners that want to be in full control. With our previous solution, we had a web interface, and it was tricky. And now we can give them access to the service directory, and they say, okay, I deploy a new service. It's called like this. It has this FQDN, and it's the web server has to listen on this port, and it's an Apache 2, by the way, and we can simply ship that. And another great thing is we can easily sanity check what they are defining there, because if they say this FQDN has to exist there, we can simply check in DNS, and this goes for the groups if they exist or not. And yeah, it helps us with consistency. This brings us to our HAProxy configuration. So, as I already said, we are making heavy use of the defaults. So, let's say we have a backend that is in the group Typo3 cluster uni production. We can simply resolve all hosts that are in this group and know, okay, those are our backend hosts. We know the web server is listening on a certain port. Then we know HAProxy can reach the web service there, and also NetFilter will allow HAProxy to access the web server on that port. And we are mostly using templates to generate all these service application configuration, which is triggered by the admin or even the service owner. They can say, build me this service. They see, okay, if the following files have changed, maybe you want to review them or not, and then write them to disk. So we have a stable configuration. Then if the admin is fine with it, they can simply push it out or wait for our hourly deployment. So, to the lessons learned about building something like this. a lot can go wrong. So first of all, communication is always key. And describing a service is actually pretty hard because sometimes you're not using the same vocabulary, and so we all had to get on the same page, which means which option actually triggers what. We had a case of faulty firmware, which led to an open BGP session that even though the link was nearly down, so Anycast would still try to serve packets to one of our HAProxy servers. So that went away once we got a better firmware, but we will add BFD to improve recovery time and detection. And also, automation always has a price, and this is complexity. Getting someone up to the level to understand how we are doing things is, yeah, it takes some time, and it's not like, yeah, here you have your Ansible playbook, deploy this, and you're done. But, and closing, yeah, things are not as simple as you might think. But what are actually the benefits? And this is a wide variety. We have currently a consistent deployment for everything, and this is the first time ever we know, okay, we have machines where other departments can get root, but we know they are consistently defined. And this even goes to the monitoring, because in the past, we had systems that weren't even monitored, and then we get a call, hey, why is my machine down? And we said, oh, we didn't even know this existed. The IPv6 migration is really easy, because we can simply turn on, give the FQDN and IPv6, build the configuration once again, so HAProxy listens on that IP. It gets automatically announced by BERT, and then we're done, because HAProxy is a nice 64 gateway. We don't even need IPv6 for the backend. We have fast reconfiguration, because if I change something in this defaults file, I can rebuild a whole batch of servers in seconds. And it's really cheap. It's really a cheap solution if we compare it to our old big IP solution. And also, we have no vendor lock-in. And what I like best is it's future-proof. If we ever say, OK, we are moving to the cloud, or we are doing Kubernetes, or some other fancy technology, we have a consistent definition of what a service is, and we can simply apply this to our new technology, because we have written it once, so we can simply reuse it. And also, security is always a nice benefit. If you have any questions, we are done for now.
OK, thank you so much.
OK.